All right, today's lesson is solving inequalities with special solutions. The homework is a worksheet. Tomorrow, problem of the week, benchmark, blah, blah, blah. Here are the answers to last week's homework. All right, I want you to find this question at the top of your note page. We're solving inequalities. Here's my middle. Today, we are solving inequalities that have variables on both sides. Okay, so just like solving equations, first thing I want to do is simplify both sides if necessary. In this problem, I don't need to do that. Now, the one rule that I want to say here, where do you always want your variable at the end of an inequality problem? On the left. So, when we have variables on both sides in equations, you can either bring the 4x over to the left by subtracting 4x, or you could bring the 6x over to the right by subtracting 6z. But I highly recommend when you are solving inequalities to bring the variables over to the left. How do I move that 4z over to the left, Justin? Subtract 4z from both sides. So I'm going to have 6z minus 4z is 2z. Minus 15 is less than 11. Now what? Add 15 to both sides. So I have 2z is less than 26. Divide both sides by 2. Z is less than 13. Now, I am going to rewrite this problem because I want to prove something to you. So, my recommendation was to bring the variable over to the left because that is where you want it at the end of your inequality. How about if we decided to bring 6z, over to the right? Well, watch what's going to happen. That's 0, so I'm left with negative 15 is less than negative 2z plus 11. Now I need to subtract 11 from both sides. So negative 26 is less than negative 2z. I need to divide both sides by a negative 2, which means I'm going to flip my inequality. That will become a greater than. And then I need to transpose my answer because I want my variable on the left. So z and 13 swap places. Look, point each side towards z, point each side towards z. You do end up with the same thing, but it takes a little bit longer. Bringing it over to the right to just bring it back over to the left. So I always recommend bringing it to the left. Some kids like to just keep the variable positive, so they like to move it however that helps, but it doesn't matter. All right, let's try this problem. What would you have to do first on both sides here, Lexi? Yep, and what are we going to do? Tell me what it'll look like, Lexi. Yep. So Lexi used the distributive property appropriately on both sides. What should I do next? Casey? By doing what? I would recommend subtracting 8m because you want your variable on the left. So on this left side, I'm going to have negative 12. 3m minus 8m is negative 5m is greater than or equal to negative 28. Remember, you only switch the inequality if you multiply or divide by a negative. Now what? What do I do next, Thomas? So I'm going to have negative 5m is greater than or equal to what? Negative 16. Now, divide both sides by negative 5. M, switch your inequality, is less than or equal to, what is that? 3 1/5? And it's going to be positive. Questions? All right, I want you to write down this black problem. 4 times the quantity x minus 3 is greater than 3x minus 5 minus the quantity 7 minus x. Make sure you copy it just like I have it up here. It's a pretty involved problem. And again, we need to simplify both sides. What will the left side look like, Paige?
4x minus 12.
Yep, is greater than. What do I need to do over on this right side, Chloe? Very good. You need to recognize that that is negative 1 times that quantity. So I'm going to have 3x minus 5. Negative 1 times 7 is negative 7. And negative 1 times negative x is positive x. This side, 4x minus 12, is greater than 3x plus x is 4x. Negative 5 minus 7 is negative 12. Now, let's gather our variables. Negative 4, subtract 4x from both sides. And I end up with negative 12 is greater than negative 12. What do I write? No solution. That is no solution because that statement is false. If this was an equation, let's pretend it was an equation and everything else worked out, and I got that. What would you write? This is the identity. Because that is always true. Every number in the world makes this true. But that's false. So it is no solution. Do not fall into the trap of seeing negative 12 and negative 12 and telling me that that's the identity. This is not the identity because that is a false statement. So it is no solution. Again, this is just like solving equations, except it has a greater than or a less than, and if you multiply or divide by a negative, you need to switch to inequality. All right, write the green one down. 2 times the quantity x plus 3 is less than or equal to 2x plus 13. What will I'll let you copy it. What will I get when I simplify the left-hand side? Let's see. 2x plus 6 is less than or equal to 2x plus 13. Subtract 2x from both sides. I'll have 6 is less than or equal to 13. Is that statement true? Is 6 less than 13? It says, listen, is 6 less than or equal to 13? And the answer is yes, that is true. So what should I write for my answer? This is the identity. All real numbers. Now, the one thing that I want to make clear, pretend I was solving something and I ended up with this. Pretend I went through all my work and I got that as my answer. How many solutions does that thing have? How many solutions does this have? It's still an infinite amount, right? It is not called the identity because it is not every number, but it is every number that is less than or equal to 2. So the graph of this, here's 2. What kind of circle will I have on 2? Everybody? A solid circle, and I will shade down to the left. There is an infinite amount of numbers that that are 2 or smaller. You can't say identity for this, but you also can't say that there's only one solution. There is way more than one. Here, identity means every single number. So if I wanted to draw a graph of this, I'm going to put 0 in the middle. Wouldn't it be the entire number line shaded in? Every single number in the world will make that true. Over here, there is no number that makes this true. Question. All right, let me